Now, as we're using the special CISA top plate holder for our samples, and this is all going to be part of our CISA workflow, we've selected so that the system is going to take images of these fiducial markers in the corner of each of the corners of the sample. That means later on, once we align everything in maps, those can be used to help align the samples, so that all of our data from XPS and the SEM are all in the same position and all correct. So it's going to move over to the first fiducial point, adjust the lighting so that it takes a nice image of that sample for recognition. And then it's going to move to the second fiducial marker and repeat the process. It'll do this for all 4 markers. Okay, so now we're ready to take our analysis. So it's moving to the first point, and now it's going to be moving the stage up and down. This is the auto height routine, so it's going to find the optimum position for analysis. So we'll see the sample going in and out of focus, and then as it finds the correct analysis position, that will come back into focus, and then it will start the analysis. Okay, so now it's found the auto height position. It's taking the survey spectrum here. So if we want, we can drag that across and open that in a new processing grid here. So we can see our survey spectrum here. And immediately after a single scan, we can see the signal to noise ratio is actually very good. So let's reduce the number of scans down to 5 from 10 to speed things up a little bit. So if we wanted to, we could start to look at this survey spectrum before it's even finished. So if we go to the manual peak ID tool here, open that up, and then we can start to select elements that we think are present in the sample. So we know there's molybdenum, so we can click on that. We can see it's highlighting the molybdenum peaks there. We can see a strong molybdenum 3D there, so we'll get a nice signal from our high resolution scan. But if we select the sulfur peak, we actually don't really see anything. And if we zoom in to this region here, we don't really see anything from the 2S or the 2P. So perhaps this sample has degraded over time and there isn't any surface sulfur there within the structure. Perhaps it's over-oxidized or just degraded over time. Okay, so now that's finished the 5 scans. It's moved on to the molybdenum scan now, and we can see that coming in here. So again, we're not really seeing any sulfur. This isn't really the structure we'd expect from molybdenum disulfide. But if we wanted to check that further, what we can do is look to see what the knowledge view has based on this for this element. So if we right click on the spectrum there, and down here we can see, we can click on show XPS knowledge for this spectrum. And if we open that up, we've got lots of information about molybdenum. So let's put that side by side and maximize the molybdenum so we can look at that. So we're definitely looking at sort of oxide of the molybdenum. And if we scroll down here, we can see what molybdenum disulfide should look like. And here, this is the telltale sign. So we should see the sulfur 2S peak around 226 EV, and we're not seeing it. So yeah, this looks like there's no sulfur left on this sample. And now that's moving on to the second point. So once again, we can start to look at the survey before it's even finished acquiring. And immediately we can see differences here between this and the original point that we were looking at. Let's look at where the molybdenum should be again. We highlight that this is a much smaller peak than we were seeing in the first point. So that suggests that not only has this sample not got really any sulfur left on the surface for a molybdenum disulfide, the surface itself, the coating, is not actually continuous. There's some variation on the surface as well. So that's something we can investigate a little bit further. And in fact, if we wanted to, we could overlay these two survey spectra. So if we select both of them and go to compare overlay and select lightbox compare, and then when we look here, maximise this, we can see immediately there's a vast difference in the amount of molybdenum on the surface between the 2 points.